Hi guys, welcome back to my YouTube channel APM Guide. As a part of our APM Gestures series, in this video we'll see how to perform Fling gesture using W3C Mobile Gesture API. Okay, and we discuss about the performing Fling gesture based upon the area, that is the Fling bounding area. Okay, and in this video I will discuss about how to calculate the Fling bounding area. Okay, in previous videos we have seen how we can perform the Fling gesture on the element. Okay, now we basically discuss about the Fling bounding area to how to calculate, how to perform this one. Okay, so the first of all, for Android we have 9W3C mobile gestures commands. Okay, to perform Fling gesture we had to use the command called mobile::fling gesture command. Okay, so what exactly the mobile::fling gesture command all about? Okay, see, by using this command we can perform the Fling gesture on a given element or a area. Okay, so in this video we're talking about the area, so we'll concentrate more on area here. Okay, here area means Fling bounding area. Okay, the supported arguments for this command is elementId, that is the ID of the element to be flinged. If the elementId is missing, then we need to provide the Fling bounding area. Okay, if we provide both elementId and Fling bounding area, then the area will be ignored. Okay, and we have four main command arguments for defining the Fling bounding area, that is the left, top, width, height. Okay, so we should know what exactly these arguments talk about. The first one is the left coordinate of the Fling bounding area. Top is the top coordinate of the Fling bounding area. Width is the width of the Fling bounding area. Height is the height of the Fling bounding area. So I will explain it in diagrammatic. Okay, and next one is the direction. See, direction of the Fling. By using this direction argument, we are defining the direction of the argument of the Fling here. Okay, and it is a mandatory value, and the actuator value for this direction are up, down, left, right, and these are case insensitive. Okay, and next one is the speed, the speed at which to perform this gesture in pixel per second. Okay, and the default value is 7500 into display density, okay, of the mobile or emulator. And by using this command, it return a value. The return value will be type of boolean 1 and equals to true if the object can still scroll in the given direction. Okay, and this is the example how exactly our code look like. Okay, now we will see. First of all, we'll see the example what we need to perform the Fling here. Okay, open the emulator. So I had to perform a Fling, okay, on this image, on this element here. So I had to move this like this. Okay, and previous video we have done based upon the element, but in this video based upon the Fling bounding area. So I had to move this image to go to next image here. Okay, for this one I had to use the Fling command, but here we are mentioning the Fling bounding area. Okay, so what exactly Fling bounding area here? Okay, what I did here. So what is Fling bounding area? Now how to calculate it? Okay, so what I did, I capture this screenshot here in the bitmap here to demonstrate the Fling bounding area. So if you observe it, here I am facing my finger on the center of this image, of this element, and then I am moving to perform the Fling direction right. I had to move my finger, I had to place my finger on the center, then I had to move my finger to the left side. Okay, see here, you see, from center to left I am moving so that I can perform the Fling on the right direction. Okay, so I had defined this boundary here, Fling boundary. Okay, so what exactly here? See, if you observe this bitmap here, so I am placing my finger here. Okay, then I am moving here. See, So this is the fling bounding area. Whatever you see the rectangle, dotted rectangle, right? This is the fling bounding area. Okay. So here the top left. So here we are talking about these values, right? These values, top left. Okay. So this is the value. This is the value. You can see the arrow here. This is the top left. Okay. And width. So from this point to this point is the width. This is the width here. So you can see my plus symbol here. So this is the width and height. This is the height. You can see, observe my icon here. It is a plus icon. This is a height. So this is the top left corner and this is the width and this is the height. So we have to specify these four values, and if we specify these four values, we are getting this flick bounding area. Okay. So this is how we need to calculate. This is, we understand the flick bounding area. Okay. How to calculate it here. Okay. So I got it that you understand this, what is the flick bounding area. So from here, this is the flick bounding area. So, okay. And we need to calculate the flick bounding area. Okay. And we should know what exactly, we got to know what exactly this top left corner. Okay. Top left and width and height. This is top left and this is width. This is width and this is height. Okay. See, basically when you say, so we'll see what exactly the top left, width and height. See, when you say left, right, so left represents the x coordinate and top represents the y coordinate, and width represents the x coordinate and height represents the y coordinate. See, in a mobile, when you say top, right, means this is the one from top. See, basically the top and left and top will calculate from here, 0 to 0 here. Okay. If you move in horizontal direction, okay, this is the x axis, and if you move in y direction, this is the top and this is the y axis. Okay. So for this one, I have clearly explained the how exactly we need to calculate top left. Okay. In my previous video, okay, I place this in the icon, just click on that one. Okay. Now we got the left and top here and width here. See, I am placing my finger here, okay, and moving here means the top left corner is, I had specified this value, the center of this element. Okay. So by center of the element, I'll get the x value which represents the width. The y value represents the top here. Okay. And I had to move the this way. Okay. So I need to calculate the width here, the width of this one, the place from middle to this one, right, to this one. So I had to calculate the width here. So one thing you have to keep in mind that when you are performing a fling on the direction left and right, the height is not needed. Okay, but it's a mandatory field. So height, no need to calculate it. We can keep it the same, because if you see in this one bitmap, okay, if I'm moving like this, okay, I had to move. See, I have seen here, right? So here I am moving the width here, means x-axis. Okay, x-axis only, because from top I am moving to left. Okay, so only width is enough. No need of height. Height should be same. So height should be same. See, if I am performing here, so there is no need of height here. The same thing, okay, I had to do here. See, from here to here. So there is no need of height. Okay, the height will be same. Whatever the height here, it is same here. So only the width will change. When you see this thing, you note when you are performing the fling operation on left and right direction, so no need to calculate the height. Keep the height same. When the height comes into picture, when you are performing the fling in up and down direction, then the height will consider. Height comes into picture. Okay, then we need to give the height value, and width will be same. Okay, so this thing we need to keep in mind. Now coming back to our notepad here, you can see here. So I told that. So the left represents the x-axis and top represents the y-axis. width also represent the x-axis and height represent the y-axis here. So if we take example here, the width and height of element, the width is 1000 and height is 1000. So I need to place my finger on the center. So I need to calculate the center of this element, means it should be 500, right? 500, and here it is should be 500. Okay, 500 has to come. Okay, I need to write the code such a way that I can keep my finger here. Okay, so first we write the code here. Okay, we come to Eclipse, then I need to create a class here. I need to, as we know, we used to create the class under the demo package. So this code, after finishing, I'll put it in the GitHub. Okay, and I place the GitHub link in the description here. So I say Fling area demo. So I give the name for this class as Fling area demo. Okay, so quickly I'll get the setup and tear down methods here. Just copy paste here so that we can save the time. Just remove this package name and just change the package name to demo. Yes, and the class name I need to rename from sample to Fling demo, area demo. So just quickly I have given the setup. Okay, and here I had given the capabilities like platform name, automation name, device name. Okay, and tear down I have given this one. Okay, now we'll come back to the text here. The first of all I had to open this app to perform this one. Okay, so I had to close this one. So we had performing the Fling on this one screen, right? So I had to open this app, Organic Bazaar. Okay, and I need to go to the screen, right? So I need to click on, click on this flower seeds here. Okay, so they quickly open the Appium inspector to get the strategy and selector values. Appium inspector getting started. Just given a capability, I save the capability here. A sample I given this platform name and automation name. Just before starting the session I need to run the Appium server also. Open the command and say Appium server. Appium, that's it. So my Appium server is started. Okay. Now click on start session so that we can capture the strategy and the concern selector values. Meantime, I had to open this app, right? So I had to use the method called driver dot activate app, and I had to give the package name. Okay, so I get the package name, the Appium inspector. So I need to click on this flower seeds, right? So this is the package. See the package name, I got it here of that particular app. So enter this package name here. Okay, by using this command I am opening the Organic Bazaar app. Okay, the next one is the, I need to click on this image, right? So this is the selector value and this is the strategy. So this is the Android UI automator. Okay, come back here and say driver dot find element Appium by dot Android UI automator, and I give the value here. So here I need to click on that one. Give it a click. Okay, the next, after clicking on this one, I need to click on this marigold orange flower. Okay, so go back to the Appium inspector and refresh, and just refresh this one so that the screen will change. Okay, yes, click on this one and get the, so the here also it is add better. So what I will do, just copy this one, paste it here and change the select our value here. This is location locator value. Go back to API inspector and just click on here. Okay, the same operation I need to click on here. Okay, so here I need to perform the fling. Okay, so I say perform fling gesture fling gesture direction. I give direction to right. Okay, so I am moving this image to right here. Okay, this side. So the same thing I want to print in the console. Okay, so first scenario what we'll cover is I will perform the fling. Okay, so first image to second image I'll go. Okay, direction is right. The second scenario what I will do, I'll go back to first image by performing the fling direction, giving direction on the left, but all this thing on the by calculating the what do you say fling bonding area. Okay, these two scenarios we are covering here. Okay, just I copy this one. These two scenarios will perform here. So this is the right, this is the left here. The two scenarios will cover, and based upon the fling bonding area. Okay, now the first one. So now we need to write the code here. Okay, first I say driver. I need to cast it into JavaScript executor. Okay, now I use method called execute script, and I need to the key has mobile space fling. F is smaller case and G is uppercase. Okay, so this is a command name to perform the fling. Okay, this is a command name. So this is a command name I give as a key here. And now we are using set of argument size. So I had to use immutable map of. So immutable map of I had to give the argument details here. So we have not using the elementId, so we had to use the fling bonding area. The fling bonding area we can calculate by using left, top, width, height. So this is the key for us. So just give left, and then top, and then width. Height. So define the keys here, the value you need to provide. And the mandatory field, you know the direction, right? Direction is a mandatory field. Okay. So direction, the first one is I had to use the right direction to go to second image, and the speed. Okay, the speed I'll give the default speed here. Okay, and now I need to give the values here. Okay, so I need to give the values for the left, top, left, width, and height. Okay, so I need to get the calculate this elements center so that I get the top and left here. Okay, of this element. So this is the element. Already we have the element here. Okay, so not have the element. Okay, just a minute. I just refresh here. this is the one. So you automatically just, what I will do, I'll just take this one. Okay, I don't want this method here, and I place this thing into the element variable, okay, of type web element. Okay, now I need to calculate the center of this element so that I get the top left. Okay, so how we can able to calculate the center? See, element dot get rect. I use the method called get rect dot, okay, width. I use the dot get width. Okay, so that I get the, I am calculating the value of left here. So you know, right, left represents the x-axis, that is the width here. Okay, as you tell, left represents the x-axis and width represents the x-axis here. So I had to use element dot rect dot width, and I had to into 5.5. okay, so I get off here. Okay, and I need to convert this value into the int. Okay, and I have to hold this value into the, I say as center x. Okay, and this will be type of int here. That's it. So I got the x-axis center of this element, here, of this. Okay, and I want to get the y also. So just copy this one and just say center y. So for y we have to give the height. So height represents the y-axis. The center. So now I collected the center here. So I am placing my finger on the center. Okay, so this is the top left here. Okay, and left represents the x. Okay, I given the value here. Okay, now top left represents the y axis here. So I given the center y. So I got this one. Now I had to get the width and height. So for performing this fling to right direction, I had to place my finger here and I had to move in this direction. Means my y axis is decreasing because I am going towards the negative side here. If I go this side, it is positive. This is the negative here. So I had to give the value such a way that my finger will place here and then it will move to here. Okay, so what I had to do here? So same thing, just calculate here. Okay, copy this one. Okay, I copy both. Okay, and then I placed here and I rename this thing as width. Okay, width, and this is the height. I say height y and width x. So you get a difference here. As I previously told, okay, in this bitmap, if I performing this thing in the left and right direction, the y value, that is the top value, remains same. Only the x value will change. That is the width will change, height will remain same. Okay, so get back here. So what I will do, the height I will keep the same one here. Okay, height I will give the same one. So I got this value also. Now width, what I had to do, I had to decrease the width. So I had to go in negative one. So I had giving into 2.2 here. So if you come here, notepad is 500, right? I am making into 2, right? So it will be 200. Okay, it will be 200 here. And because as you know, see, calculate the width, right? See, 1000 into zero point 0.5 is 500. Okay, and now what I had to do here, 1000 into zero point 0.2, that is a 200. Just a minute. 0.2, that is a 200, means I am going negative direction. So in this direction I am going. So in this direction I am going. So from 500 to I am going to, I am specifying the width to 200 so that my finger will go here. Okay, this is the one. 500, this is 200. Okay, so come back here and just provide this value here. That's it. We got the all the values to specify the vertex. Okay, so we got the fling bounding area. So left, top, left, width, height. Okay, I'm not providing the speed value. I'm taking a default value here. So this is the direction to right. Okay, now we need to calculate to left here, left direction. See, by performing the fling to right, I went to the second image. Okay, now I had to come back to the first image. So what I had to do for the performing this one, I had to move towards the left direction. Okay, and my fling bounding area will go here. You can see my dot here. So I had to give the width plus here. Okay, so if you see one in bitmap, so in previously we went this direction. Now I want to go this direction here. Okay, so I had to place in the center and then I had to go to this one. So no need of giving y-axis, that is height, because as I told, the fling left and right, mainly we had to give the width only, no need of height. Okay, so I had going from center to this direction, mean my width is increased, means my x-axis should be increased here. Okay, so come back to my here, this one I had given into 2, right? Now I went here, so I get the same value here. Okay, and I will give the values here. Okay, to differentiate here, what I will do, I will give x1. Yeah, no need of giving this one. Okay, just a minute. What I will do, I will define here. Center y. Okay, so that I can remove this one here. Same thing I'll do here. Y to q, all this thing. Define this one. Say width also, height also. Height y. Okay, so I remove this one. Okay, now also what I will do, just copy this one, let's replace this, remove this one and paste it. Okay, now I had to increase my width, so what I am doing is here into 8. Okay, so there is no need to change the height, because you see here in bitmap, see I am going from this direction to center to this direction, sorry, to here. Okay, so this direction I am going. Okay, so width will be increased. Okay, and height remains same. Okay, so this one from here to here. So come back to our code here. I say 0.8. So what will be if I say 1000 into 0.8? It will be 800. Means I am increasing width here, means I am giving the positive value here, so it is 8 here. Okay, so same code I had to use, just I need to calculate here, right? I already calculated here. The only thing I need to change is the direction, left direction. Okay, left direction I given here. Okay, and here I mentioned one more value, speed. So I add the speed also. So I say the speed, I provide the speed value also. Okay, and I give the speed as, I calculate the speed here. Okay, so I say int the speed value variable I have created, and just say the default is, you see here, the default is 7500 into the display density. For this display density I have 2.625 for this emulator. So convert this thing into int. Simple. And provide this variable here, value here. That's it. Okay, so what I will do, I'll just decrease it. Okay, I want to move it slowly. Okay, so that you can see the effect here. Okay, here, so our Fling bonding area is calculated here. So yes, so I'll give the TED.sleep so that you can see the effect, and we can discuss also. TED.sleep. This I give the 3 seconds for each and step. Same thing I use here. Okay, and then after performing this one, I want to wait for 3 seconds. Okay, that's it. Yeah, everything is done. Okay, this is right direction and this is a left direction. Okay, now open the emulator here and just close this app. My Appium server is running. Yes, it is running. Now I run this code. So it has to open the organic bazaar. Click on this flower seeds, click on the marigold and perform the fling direction to right based upon the fling bonding area. Open the organic bazaar. Click on the flower seeds. Yes, click on this marigold. Be fast here. Just a minute. I need to give some more time here. Say 5 seconds. There's a problem synchronization here. Once again. Click on the flower seeds. Click on the marigold. Now I have to fling to right based upon the bonding area, fling bonding area. Now I had to come back to the first image from second. See this feed also, see you could decrease, right? So this is how we can able to use this, define this fling bonding area by using these variables, left, top, width and height, these variables. So what I will do, I'll run one more time. You can see this one. Then I'm running it. Open the organic bazaar, click on the flower seeds, click on the marigold and perform the fling towards right direction by using this fling bonding area. So this code I'll put it in GitHub. Okay, and same thing will be available in the Medium also. Click on marigold And first do the fling gesture towards right, and then you can see the speed also, different speed. So in first one I had the default speed, and second one I had used a slowly, as you can see. So this is how we can perform the fling gesture based upon the fling bounding area. Okay, if you like this video, please click on like button, subscribe to my channel. Thanks for watching. I push this code to the GitHub also. Okay, and it's available in the Medium. Okay, thanks for watching. Bye, take care.